I'll start by telling a story because that's what you're supposed to do in presentation school, right? So we had Kelsey, who I guess kind of stole my thunder this morning. I will not be deploying it. Well, I will try at the end to deploy something via my phone. We'll see how it goes. But the interesting thing that he said was, when you walk up to the booth and you see someone and you automatically assume they're in marketing because they're in the booth and that's what they should be, right? And of course, a lot of you are just like, oh, great, product marketing. That's going to come and tell me something technical, right? Let me make sure this person's not in the room. So I had an individual last night at dinner, and he's like, what do you do? And I'm like, I do product marketing, and I mainly focus on Habitat. And then we start getting into a conversation, and we're talking about the way Habitat works and some of the things that we've been doing and other more technical topics. And he's like, wow, you're really technical for someone who's in marketing. And I'm like, well, yeah, I do actually have, multiple computer science degrees, and so I've actually worked in operations, and I've done a lot of the things that I'm going to talk about. So even though I have this title of marketing, please, let's all include each other as brethren and sisters here in the technical world. What was that? Yeah, you don't want to look at my GitHub. All right, so a couple links for you. Of course, a lot of people have laptops open. You might have your phone open. If you're at any point in time you want to kind of look up something that I'm talking about or learn more about Habitat, these are kind of the best places to go and look for information about Habitat. Start by joining the Habitat Slack team. It's a very active community. Every thing that we do development-wise is developed in the open. So all of the development work that people you've heard this week, Adam, Jamie, Fletcher, and everyone else, they're all working in public in this Slack team. So please join it and ask any questions. And then once again, it's a totally safe community. If you're a super beginner and you don't know, feel free to ask and don't be intimidated because there's a lot of things that we may not necessarily know yet either. It's a kind of a relatively new open source project. So I was at KubeCon, and at KubeCon, someone talked about how there's different generations of technologies, and she compared the different generations of technologies from like the broom is like when we used to configure systems by hand on bare metal, right? Anyone do that? Hopefully. Like 2 of you, wow. And then the vacuum cleaner is like where we have VMs, and it's a little bit more automation, and then you start using something like Chef or Puppet to automate the deployment of those VMs and configuration of them. And then the Roomba is kind of like Kubernetes and containers, and it's just magic and automatic, and it's beautiful, and your life changes. And your life changes kind of like this. So everyone's seen Habitat, right? So Habitat is something that we've come up with. So this is kind of like Habitat just running around. And that's enterprise IT being like, hey, you shouldn't be using containers or Kubernetes or whatnot, and the Habitat's just like, get out of my way. And then, you start using it more and more, and the experience is really good, so it's really powerful, and people want to follow you around, and you get maybe a little bit of an attitude, and you start dressing up as sharks. And then, of course, enterprise IT sees that what you're doing isn't going to go away, and so they kind of build you a container solution that's not really a container solution, but they dress it up like a container solution. But automation's not all it's cracked up to be. So this is a real video from the internet. I've just taken screen caps because it's easier than playing the video. The second rule of Presentation Club is you don't show videos in your presentations. So there's a dog, and of course the dog wasn't let outside that morning and is having a little bit of an accident. And, of course, as dogs do, they're inspecting it, which is all important for all of you. Good colon health is something that's very important. I've had family members with colon cancer, so you always should look down when you're done. And here comes automation. And the Roomba's just doing what it's told, right? And it's going to go clean up. And I was showing these slides to our CMO, Ken Chaney, who you saw earlier on the main stage. And he's like, I totally have had this happen to me before. So, like, this is real. This happens. It's more common than you think. And then the automation's just going to go pick it up. And then the next thing you know, your automations went and took and spread shit all over your house. All that being said, not to knock on Kubernetes or containers, but if you're not careful, it's very easy to go and easily spread shit throughout your entire data center. So And this is kind of encapsulated by something that we've been talking about all week, is this idea of this learning cliff, right? Where in development, containers seem really, really cool and really awesome. But then when you go and actually try and deploy it out into production, that's when you get into this learning cliff of containers. And there's all these complicated things. Well, not complicated. A lot of these things are being solved and have started being solved as containers become more common. But there's all these things that you have to think about, right? And one of the biggest ones is this idea that containers aren't a VM, right? And this is kind of one of the foundational principles that companies like Docker and so forth have preached for a really long time. And Kelsey gave a great example of treating a container as a VM when he showed how you went and built that container in that Docker file on the main stage, right? Kelsey has another great example that if you can look it up, where it's building a minimal container image, and that's basically where you have about 4 lines inside that Docker file, and you're not including and shipping a whole operating system. So containers aren't VMs are the best practice, but are you really sure about that? So how many people are using containers just like they use VMs in the room? You don't need to raise your hand. We don't need to shame you in front of your peers. But you can look at a few statistics. So I forget where the first one came from. I want to say the first one came from a survey that RightScale did. It was either RightScale or Datadog. And they looked at usage of containers of their customers, and they found that there was about a 4-to-1 container to host ratio. So what does this tell us, a 4-to-1 container to host ratio? If anyone's done any form of capacity planning. Them's VMs. Thank you, Nick. I knew I could rely on you. I've got a 20 for you later. And then another one, which comes from somebody by the name of Gareth Rushgrove. If you don't know who Gareth is, Gareth works for Puppet. But Gareth is a really nice guy. I was looking for a little bit of more of like, because we're feeling sorry for Gareth, right? Gareth does some excellent work in the DevOps space. If you don't follow him, you should totally follow him on Twitter. He also does something called DevOps Weekly, where he sends a newsletter out every week with kind of like top links and stories in the world of DevOps and tooling and other stuff like that. So definitely check out DevOps Weekly. He did a talk at Config Management Camp, and his talk at Config Management Camp, he was basically doing GitHub queries. So all of GitHub's data is up in BigQuery, and you can query it and do different reports and stuff like that. And what he was looking at is that he basically went and found that 75% of containers container a full OS. I just realized there's a typo there. But I read it the way it was. So containers container a full OS, right? And so, like, are we using containers the way they're supposed to be? Probably not, no. But the thing is about the way the container ecosystem works, and really, I guess, kind of with Docker files in general, and I've always had a little bit of an issue with Docker files, mainly because it put us back into the world of bash scripting again. But then, of course, what I'm about to show you with Habitat puts us back there as well. I think we've accepted our fate at this point. But it's super easy to just pull in that full operating system that you really don't need anymore in a containerized world. So how can we start to begin to build containers better? And then when we build these better containers, how can then we ship them out to actually go and run them? And if you think about it, there's a new program that a very popular container company just started that's called Modernized Traditional Applications. And the modernized traditional applications are all about lifting and shifting your technical debt for fun and profit. So they'll just package it up. Who's ever done a P to V migration? Physical to virtual migration, right? And what did you do? You picked up all that crap that was on that physical machine that's been accumulating for the last 2 or 3 years, and you moved it onto a VM because that was somehow going to be good for you. No offense to VMware. I think there's someone with a VMware shirt back there. But that doesn't actually solve the actual problem of managing that system any better than what you managed it from to begin with. And then what you end up having is you're just going to have more and more and more VMs, and your complexity problem just grows and grows and grows. So let's talk about what modern applications mean. So that's kind of some of the problem set in the container world. Let's talk about modern applications and what we mean by modern applications. So modern applications need to basically be service, or the way you communicate and work with a modern application, it should be API first, right? So it shouldn't be some particular tooling that you can't expose the API, and a very REST-based API is kind of the standard. So that should be your interface in and out. And then you build your tooling after you've already went and built your API to interact and manage the application, right? This is a very common thing that you see with a lot of cloud providers, right, where they're going to go and provide that API, and then they backfill in and provide the SDKs that interface in, or the CLI that interfaces in with that. And the thing that you have to think about when you look at this world of API first is it's all about consumption. So what you're trying to do is you're trying to actually solve an economic problem to make it easy to consume, right? And that's why APIs are great, because if you have a very good API that can be accessed programmatically, it's easier to consume it. And then thus it's easier to use that service in the proper way, right? You should have a small area of concern. So for each individual application, you should try and minimize the footprint for what it's actually managing and trying to do, right? And this is one of the things that you can see in microservices-based principles, right? They should be ephemeral, or they should be able to be managed in a stateless way. And of course, we see this with things like Platform as a Service, Cloud Foundry, other services like that. Of course, don't be fooled. You always have to go and store data somewhere. A lot of platforms make you think that your data just they don't answer the question of where your data goes. So your data needs to be stored somewhere, hopefully accessible via an API, and that would be something like maybe a data service that you get from one of your cloud providers, like RDS, for instance. And then they should focus on artifacts and the building and deploying of artifacts. And so Kelsey talked about something one time at a conference. It was called Container World. And his opening line is you wouldn't have a conference called RPM World, would you? Let that sink in for a minute, right? Like, containers are just a packaging format, right? It's just a way to generate an artifact, right? I was going to say, you wouldn't have something called VM World, would you? And I was like, oh, wait, you would. All right, and so Kubernetes, if you look at some of the foundational principles behind Kubernetes and Habitat, it's really about this idea of running modern applications, right? So what do we mean by that? So Habitat is built around this idea of API first. So how many people think that an API is just limited to how you communicate with something over a network? Good, nobody raised their hand. We always forget that the first APIs were in your header files, right? And that's actually defining an API of how you interface with a library, right? And so from an API perspective, you have APIs when you look at what you do with configuration management, right? And when you write resources in Chef, or when you write testing in InSpec, that's essentially writing towards an API or writing towards a spec, right? And so with Habitat, we do it from two perspectives. So in the very first thing that we do in Habitat is we define an API of how you build your software artifacts. And then the second thing we do is we have an API of how you run those artifacts in production. And then, thus, we focus on building those artifacts. And this is really important, and I'm going to dive into this a little bit here in a second. So I'm going to skip that for now. And then the other thing that we do is we eliminate the dependency on the operating system. And this is really important because when you go back to this idea of how you should properly run a container, where you're not pulling in a full-fledged operating system, but minimizing your user space as much as possible so you just are able to do troubleshooting things like Kelsey mentioned on the main stage today, it's very important to think about how we can start to eliminate the operating system, because the operating system is the source of most of our problems. How many people have to patch servers? Why do we have to patch servers? Because the way that we've defined or designed the operating system paradigm and the application paradigm. So this boils down to this idea of operable application containers. And of course, I didn't start my timer. All right. So, yeah, I don't know if I'm pacing myself right, though. So, thank you. So it boils down to this idea of operable application containers, or even operable applications, right? So applications should be isolated from one another, basically meaning that if you modify or do work on that particular application, you're not necessarily going to destroy the entire stack. right? So if you think of the Netflix model of things turning on and off based upon the availability of that service, and sometimes you log into Netflix and you don't get recommendations, or you don't get the, I always hate it when the continue watching is 4 lines down. I'm like, why is continue watching not always up at the top? And then I understand how the architecture of Netflix works, and I'm like, They should be immutable, so the application artifacts themselves should be immutable. And this is one of the areas where Chef and kind of the traditionalists in the container world might butt our heads every now and then, and when I say Chef, the company. Because even though the application artifact should be immutable, what should still be mutable is the configuration of the application, right? Because the configuration of the application is going to change as you promote something through different environments, right? And what you don't want to have is you don't want to have container images for 5 different environments, right? And having to rebuild that container image because you're baking a lot of configuration into that container artifact. You should have a common API for monitoring health. We feel that you should rebuild from source, and you'll see this, using a common packaging technology and then having runtime independence. And when we say runtime independence, what we mean is compute runtime. So just like we now have different language runtimes, like JVMs and Ruby interpreters and Node VMs as well, you also have different compute runtimes now, right? So we have bare metal, we have VMs, you have cloud-based systems, you have container-based systems. And then within containers, you have a lot of different container formats as well. And so you should be able to take this artifact that you generate and run it on any one of those platforms with ease. So who's ever done this? I was thinking the last couple days as I was waiting until the last minute to write my talk about some of the problems that we solve in Habitat. And I was also talking with someone about when did you get started with Linux and what was your first Linux distribution? And so I want to say it was either 97 or 98. So it's either my 19th or 20th anniversary of using Linux. Oh, no applause? God. And I got started with Slackware. And then I also played around with Gentoo, right? And you kind of go through that cycle of figuring out what distribution you want to play with. But then when you wanted a piece of software, and this was probably most common with things like audio drivers at the time, right? And trying to get your audio card working on your laptop was what moved me to a Mac as soon as I had OS 10. But you kept following this cycle of you would download the package, you'd untar it, you would some logically correct asshole right now in the room is saying he forgot the CD. And then you run /configure. And then usually what happens with /configure? It fails. And why does it fail? Because you're missing a dependency of some sort. What? Because I didn't CD into the directory. I knew there would be one in the room. It fails because you're missing the dependency of another library, right? And then you're like, shit, okay, I got to go find where the header files are for this particular library. And then you download that one, and you install it, and you put it in the right place. You actually do this exact same cycle for that library you just downloaded. And then you find another one's missing. And then probably when you went to go download one of them, you would realize you were missing a whole bunch of other stuff that depends on, right? And, then your wife, which my wife is here in the back, is wondering why you were up until 3 a.m. playing on your computer. And so that's essentially what Habitat does, is one piece of Habitat automates that cycle, right? And when it automates that cycle, if we think back about, why are you stuck in that cycle? You're stuck in that cycle because you're using an operating system, and the operating system vendor has a release cycle. And as soon as you decide that you want to use that particular operating system, you're tied to the vendor's release cycle, right? How many people still manage Red Hat 5? Nobody wants to raise their hand. Oh, there we go. So how many people still run Red Hat 4, right? It's because you have some sort of dependency in your application on something in the operating system. And usually what happens of why you get stuck in that loop is because there's newer software that you want to use that your operating system vendor doesn't have the features that you want. And if you're running on something like Red Hat 6, usually, or Red Hat 7, or even a lot of other platforms, what's the first thing that you're going to install? Is you're going to have the apt cookbook configure EPEL, right? Because you need newer software. It's extra package for enterprise Linux if you don't know what that means. And that's because you need newer software to run your application. And when you think about what actually goes into building an operating system or building a system that runs something, is you have the operating system vendor-provided libraries. You have any configuration changes that you want to make to what the operating system lays down. You have application-specific libraries that you're going to install. And then you have the application itself, right? Habitat really kind of flips this on its head, right? So with Habitat, what we can do is basically what we call deterministic builds and deterministic builds of containers as well. And so we've gotten rid of this blurred line between what is an operating system shipped library and what is an application shipped library, because it's crap and it really needs to end, right? And there was a reason why we had it at that point in time, but it creates so many problems of managing systems at scale that it really is just not worth it for us to go down this path anymore. So with Habitat, what you do is you define your application. You define what that /configure make install loop is for your application. And then you can go and once you've built that artifact, you can say you want to export it. And you can export it from a Habitat package, and you can export it into a variety of different formats. And I think that's on my next slide. No, my next slide. So the idea is that you want to try and move on this sliding scale as much as possible to the left. I think I'm pointing in the right direction. Yes, to the left. And so basically, if you think about what goes into a container, you want to try and minimize as much as possible how much you're putting in the operating system space, right? And you want to try and keep it as much of application-specific code or libraries as possible, right? Now, if you look at the example that Kelsey gave, if you're using something like Go and you can compile to a statically linked binary, then there's very, very little that you need in that actual container itself, right? So with Habitat, what you can do is post-process packages. So there's a whole bunch of different, I guess, is 3 a whole bunch of different? There's a few. And I'm looking at my wife because she's always likes to clarify the definition of a couple and a few and some. And we have kids, so like that comes up often. So there's a few. Is that right? There's a few different post-processors. So what you can do is you can take that Habitat binary, and what Habitat will do is basically do this. So it'll figure out what dependencies does that application artifact need. It'll say, what transient dependencies does the dependencies need? And it'll walk that dependency tree for you. So you're not going and downloading all these tarballs and figuring out what goes with what. It does it automatically for you. It'll take the supervisor and then walk the dependency tree for the supervisor and package all of that up. And that's the process that we saw on the main stage today, right? So I assume everyone saw that, so I'm not going to go and do it again. I'm kind of explaining what that output was that we saw. And then it'll package that all up in your exported format, right? So then I can take that and I can go and run it on any platform that I want. Another one that we have that's not necessarily listed here is a tarball. So you can also export it as a tarball. So you get everything that you want, and then you can have this artifact that's locked that you can then go and ship and have all the dependencies you need in that one particular tarball. So what we think of when we think of Habitat and Kubernetes and how not just Kubernetes, but things like Mesos and Swarm play with one another is that Habitat is super good, as I just talked about, for building that container, right, and generating those application artifacts that you would then go and take to run on something like Kubernetes or Mesos or, and the like. The way that we think of the separations of duties is that Habitat's responsible for the application itself and configuring the application and standing it up. And then Kubernetes is responsible for the underlying infrastructure that you need, right? And by infrastructure, we mean things like Kubernetes concepts such as replica sets and pods and the services, right? That make an application that you can actually do something useful with. So what do applications need to run? So let's talk about what we think applications need to run. And then I'll jump in and I'll give a little bit of a demo. Hopefully my demo goes as well as the one this morning. Hopefully the demo gods are with me. If not, we'll punt and we'll figure something else out. All right, so if you think about what applications need to run is they need awareness, right? And they need awareness of a couple different things. They need awareness of the environment that they're in, and they also need awareness of their peers, right? So they need to know who's like me in this place and what is the running configuration of that thing that's like me, right? Because if you're like me, I should probably have the same configuration, most likely. There might be 1 or 2 lines in your file, in a config file, that might be unique to the particular host, but generally speaking, you want all of your application instances to be configured correctly, right? Everyone can agree with that? Yep. So what you need to be able to do is form this ring where you can communicate and have the application instances communicate with one another. And so what we did is we came up with this concept of creating a daemon set on Kubernetes. And what this daemon set allows you to do is basically form this ring so as applications come up, they have a common endpoint that they can go and talk to and find out information about what's running in that environment, right? And it all depends upon how you run Kubernetes. There's, I don't know, are they in? Yes, there is one in the room that I know of. So there's a company in the Netherlands, and what they do is they basically give, it's Schuberg Phyllis. Schuberg, wave your hand. Just one of you. Christian's not in here. So what they do is they basically have a Kubernetes cluster, and they give that Kubernetes cluster for development teams, right? And so this would work really well in that you have that daemon set come up, and anyone who's running applications on that cluster, and since it's per dev team, it's a pretty isolated environment, they have this common bootstrapping point to bring up their application instances. So let's see what that actually looks like. Sorry. So that's what a daemon set is, and then Habitat containers as a daemon set is what I just described. So sorry. I always get ahead of myself on my slides because I have them memorized in my head. All right. So you can see here, let me just go over to Sublime. I have this folder, and I'll have a link to this code at the end. And so I have this thing called a Habitat Management Supervisor, and if I look at what that YAML looks like, so we're going to create this service called Habitat Management Supervisor. I don't know why I didn't shorten supervisor, but I shortened management. And as I've been typing this out, I was like, oh, I should have shortened that as well. So if I go in and look, you can see what's going to happen is we're going to spin up this container. And it's one that we've built with Habitat, and it has just basically what we call an empty supervisor in it. And then the other thing we're going to do is we're going to give it an endpoint of this Habitat Management Supervisor service that we created. Then the other thing we're going to do is we're going to bring it up in a leader-follower topology. So let me just do this real quick. Is that 15 minutes or 6 minutes? I'm like, 6 minutes? How do I only have 6 minutes left? Okay, so I should see this service now, or these pods up. Yep. And then I can also go and look at the logs as well. But probably the thing that's most interesting is if I do this. Compute instances list. Well, I don't know why that didn't work. I think because this terminal's been open for a while. Okay. I just need to get one of these IP addresses just because I have how the service is running. And then I can go and look at this. And Okay, so this is the supervisor that's running. So I brought up a ring of supervisors. I can also go look over in Kubernetes as well. And I can look at my daemon set. So you can see there's my daemon set. That was an old window. I told you it wasn't going to go as well as it did with him. All right. And you can see the daemon set that we spun up. And I can go and look at the logs of this as well. And then I can also go and see that it's coming up. And it's having a little bit of stability problems, but it'll fix itself here in a second. And then I can also go and look and see look at the actual ring itself. So if I go and look at butterfly, I can see that, sure enough, I have a whole bunch of members, and I can see the health of each one of those members. So I spun up 8, and I have 8 in my management ring, right? So this is what you want. And then you can also see what services are running as well, service groups and other things like that. So this is the API that Habitat gives you to interact with these services. So now the second thing that I want to do is, let me go back to my slides real quick. All right, so this is the idea of having this management service. So this is going to run. And now as I bring up applications, you notice I had that peer flag. As I continue to bring up more applications, I can go and just point it at this ring, and they'll be able to find their peers very easily and then bring up their application correctly, right? So what else do applications need to run? So the other thing that applications need to run is applications aren't always deployed where they all are equal, right? Sometimes when you deploy applications, you have leader-follower type topologies that you need to go and deploy to. Of course, we all know that they were called originally master-slave type scenarios, but we don't use that words anymore, right? So leader-follower type topologies, and what you do with leader-follower type topologies is somebody needs to become the leader or the master or the one that's going to write all the data, usually in a database type scenario, and then the other ones come the followers or the replica sets, right, or the replicas, where you can actually go and read the data from at any point in time. And of course, we use that for scaling. We use it for a whole bunch of different reasons. CAP theorem is probably the main reason why we do that. So when we talk about self-organizing applications with Habitat, the way that you can do it with, so the way it's traditionally done is that you typically bake the intent into the container. So a good example of that is if you look at the Kubernetes guestbook application. If you look at the Kubernetes kind of demo application, the guestbook application, you have a Redis container that is declared the leader, that's explicitly like baked into the container that it's the leader, and then explicitly baked into the other container image that it's the follower, right? So you have 2 container images. Of course, you think to yourself, well, it's only 2 container images. It's not that hard to manage, right? But do you just always have 2 container images that you have to manage? No, you're typically going to have hundreds of container images that you might have to manage, and then thus what you're going to have to do is build a build lifecycle around those container images and so forth, right? And so it introduces this concept of image sprawl. So what Habitat allows you to do is basically build one container image. You can launch container images with knowledge as of peers, and then the application will self-organize. So they'll automatically do an election, and they'll say, I need to be this person, and I need to have this role, and then I need to have this role. I'm not going to say that they're sentient and that they're people. And when you do this, though, you need knowledge of the application organization. So Kubernetes has a great thing in it called services, which basically allow you to front end different application services. So API-driven, again, so like very easily via an API, it's declarative. You can go and put a load balancer in front of all of your applications with a couple lines of YAML. And that's what we did when we created that HAB management supervisor service. So what you can do is when that election takes place, you can actually notify Kubernetes that the election took place, and then go and configure those services accordingly based upon the results of that election. So let me show you this real quick. So if I go and look at my Redis example, so in this YAML, the first thing we're going to do is we're going to create a service. You notice that the name is Redis master. That's not what I want. Sorry. I believe this is the one I want. I had one that was modified. Sorry. Oh, because I'm on the wrong. Anyone know why? No, I'm on the wrong Sublime window. This is like someone else's code. And then this is my code, which I changed it to leader follower. That's why I knew I was in the wrong file. So I create a service for the followers, and you notice we have this thing called app, what application I'm running, and then role. So this is called a selector. So what Kubernetes will do is figure out who I should route traffic to based upon how I've put a label on the pods. And if you want to think of what pods are just simply analogous to containers, but you can have multiple containers running in one pod. And that was the example that Kelsey showed earlier where you had a pod with multiple containers, and one was a sidecar container inside of it. And then we have one for the leader. You can see that we have that selector on it as well. And then the other thing you can see is we have a deployment. So we're going to deploy in a leader-follower topology. The peer is going to be the habitat management supervisor ring that I created earlier. And then I just need to pass in some environment variables as well. So what this will do is we'll actually turn off protected mode in Redis, which you probably don't want to do. You probably want to have authentication or something. So don't actually do this at home. Well, you can do it at home. Don't do it at work. All right. So all I need to do is run kubectl on that. So very easily, it creates it for me. And then I can say kubectl get pods. And you can see there's my Redis pod. So let's look at the logs real quick. And so you can see what's going on is that there is a connection. So the first thing that happens is the supervisor starts. So what happens is when you export a container using Habitat, the first thing that as I said, you have the supervisor that's exported. So PID 0 is going to be the supervisor. So you can see that the supervisor is running, and you can see those lines there. And then the supervisor is recompiling some things and updating things, and then it realizes that it has to do an election. And so it's waiting to reconfigure the application. And so as a result of the election, it goes and reconfigures the application according to what it's specified in the config file. And the way you do that is you go to the right directory. And so let me just show you the configuration file. So I have a couple different configuration files that I use here, and that Habitat will regenerate for me. So the first one is the Redis config. And if I go and look for right here, you can see what the lines are that basically says that if I'm a follower, so this is all you have to do in your config file, right? So you basically just says service me follower, or you could say service me leader. It'll go and write out this particular line. If I'm a leader, then I'm not going to go and write that line, right? And then the other thing that it does is that it'll generate this configuration file for me as well. So it says, if my role equals leader and if my role equals or if I'm a leader, role equals leader. It looks like I can't read my own if statement. Else, I'm going to be a follower, right? Makes sense? Pretty simple, right? And then what will happen is Habitat will automatically generate these files based upon that election that you saw took place. All you have to do is specify that -- topology leader flag and have your configuration files written automatically. And those kind of distributed system problems that you have to think about when you're deploying an application will be taken care of for you. So if I go over to Kubernetes now, well, I can refresh Butterfly. And if I refresh the Butterfly endpoint here, you can see that I've got more members. How many members should I have now? I launched 5 Redis instances, plus 8, that would be 13, right? I'm just seeing if you're awake. Getting people to do math would, And then I can see the service that I have running here. Let me make this larger for you. You can see this Redis service that I have. I can see all the members of this service as well. I can find out what configuration they're running, what version of the application, and so forth, right? Now, over in Kubernetes, what I can look at is if I go and look at the services, you can see there's the leader and follower services that we created via the YAML. And what has happened is when the application starts up, the Redis instances will automatically go and tag themselves correctly in Kubernetes based upon that file that we generated, that labels file, right? So you can see I've got one here that's the leader. If I go and look over at the follower, you can see everyone else has identified themselves correctly as the followers, right? So what I can actually go and do here is modify this YAML. And I can make it 10. I know I'm supposed to be doing this via Google Assistant. Don't tell Kelsey I'm a failure. And it's complaining, actually, I need to replace. And the deployment was replaced. The services weren't. That's fine. But if I go and refresh this, I now have my additional instances that just came up, and they were automatically added. They joined the ring automatically. So if I go and look at their logs, you'll notice that they've joined the ring, and they've came up as a follower because there was already a leader created, right? So I can scale my application like that. If I go and look at the dashboard, I can see that as well. Does that make sense? So let me just show you real quick how that works. So if I go and look at the wrong file and then the right file, I created inside of my Habitat package for K8s Redis. Basically, I have this line right here. So if I have this labels file, then I want to cat those labels into a variable, and then I just run kubectl on that, and I want to say I want to label the pod of pod name. And you notice when I went and launched, I set an environment variable called pod name. So we're just using that pod name environment variable. So I told Kubernetes to please label myself based upon the configuration that I just generated. All right, so the other one, which Kelsey kind of mentioned, and I just wanted to expand on it a little bit. I don't actually have it implemented. So we have this other REST-based API, and you've seen me hitting it. And with this REST API, you can ask questions. And one of the questions you can ask is the application healthy? So all you need to do is add into your YAML a segment like this or a stanza like this, where you're going to hit this endpoint. So all Habitat applications would have an endpoint like this. So I can go and ask for the services. And I can see a list of all the services that are running. And then for any one of those services, you can drill down and get specific information about that service. So it would just be, what is this, Hab management sup. And I know we're almost out of time. And I don't have any configuration, so it's actually not showing in me anything. But you can also ask other questions. So this is all on the Habitat documentation. So let me get to a wrap-up point. Okay, so what else do we need to do? So some things if you wanted to work on it in a hack day, if you're familiar with Kubernetes. So it'd be really awesome if we had an export format for Kubernetes to where we can generate the necessary YAML that we need, maybe generate any other services as well. So that could be something that you could easily contribute into Habitat. Also having some sort of direct communication between the Kubernetes API and the Habitat supervisor. So when a container comes up, it has all of the information of where that Kubernetes API is, so you can more easily ask questions. You could also do the config thing that Kelsey showed this morning. And then also something for a third-party operator, which we still are kind of up in the air of what that would actually look like. But if you have suggestions, I'd be happy to talk to you about that, because that's a project that I'm going to start figuring out how we get underway to get development effort behind. If you want the code for this demo or for this YAML file so you can play around with it and the concept of a management supervisor ring, you can get it here. And then also, once again, any of the useful links. So we're out of time for this room. If you have questions, there's the Habitat zone upstairs, and I'm going to package up my stuff because I'm so used to Habitat. And I'm going to head up there, so if you have any questions, I'm happy to answer any questions while we're up there. Thank you.
Awesome. Thank you, Michael.